Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of second secondary, we are going to solve Elmoaser book questions. We have lesson 1 question, pages from 23 to 23. Okay, we have the kind of question, we called it open book question and sum of essay question. We have different problems we want to solve today. We will start with the simplest one. Okay, let's start. First question, here we have the molecule of element with the electronic configuration. We have 1s2, 2s2, 2b6. Okay, when we have this electronic configuration, we have the series of numbers. 1s2, it is the first energy level, second, and here it is the electronic configuration of it. When we make summation for this one, we have 2 and 2 plus 2 equal 4 plus 6 equal 10. So this is the electronic configuration that make only one atom, as we have we have only numbers that belongs to the same element and they are arranged ascendingly. So we have the molecule of element. This one consists of only one atom. Okay, only one atom. The second question here, what is the number of unpaired electrons in nitrogen 7 negative 3 ion? Okay, when we have ion of nitrogen contains 3 unpaired electrons, 3 electrons in its outermost energy level. Okay, so it needed to gain the 3 electrons. He needed 3 and gain these 3, so it becomes ions carry negative charge of n negative 3. So we have here the unpaired electrons will be, there is no unpaired electrons, so the unpaired electrons equal 0. There is no unpaired electrons. Why? As all energy levels are filled with electrons, so there is no free electrons or unpaired electrons. All electrons are present in the famous or in the shape of pairs, up and down, right and left. We have 8 pairs, or we have 4 pairs of electrons. Each one consists of 2 electrons. So all the electrons are paired, or electrons in case of ion here are paired. So there is no unpaired electrons. If we are talking about the atom, we have unpaired. We will have 5 unpaired electrons. Why? If we count, we will have what? We will have 3 unpaired. Why? When we are talking about the orbital of p orbital will contain 3 unpaired electrons, but s will contain 2 filled, and the rest in p will be unpaired electron, will be 3 that needed to gain 3 electrons also. So we must draw the electronic configuration to know the number of electrons that present in the orbitals. Okay, let's going to question 3. Which of the following molecules include 3 bond pairs? Okay, 3 bond pairs means that we have 3 electrons that forming a bond. 3 electrons that forms a bond, so we called it 3 bond pairs. Okay, we have here HBr, it's only one bond. H2O, O in the center, and we have 2 bonds of hydrogen with water. Here we have nitrogen in the center, and we have 3 bonds of fluorine, as nitrogen needed 3 electrons that reacts with 3 fluorine atoms. So this is the right answer, and this is the last one will be molecule O2, and there is no bond pair here. It's a double covalent bond inside it. Okay, let's go into question 4. What is the number of electrons required for the covalent bonding in methane molecule CH4? Okay, we want to know the number of electrons. Okay, we have here electrons that we needed for the covalent bond in this kind of compound? We have 4 electrons in the outer energy level or in the valence shell of carbon. So we have the valence electrons will needed 4 electrons that needed to gain or make a covalent bond with 4 also. So we have 8 electrons that inside the covalent bonding inside the methane molecule. Okay, what we are counting? We are counting the number of electrons that forming the bond. Okay, so we have 4 bonds, 4 covalent bond between carbon and hydrogen, 4 carbon hydrogen bond. So each one consists of one pair of electrons. So we have 8 electrons that forming the covalent bond inside the molecule of methane. Okay, must count very slowly to reach the right number. Okay, let's going to question 5. Question 5 says that what is the number of lone pairs of electrons on arsenic atom As33 in arsenic As or in arsine AsH3? Okay, we have here AsH3. We want to know the number of lone pairs. Okay, as we said that we have arsenic needed what is a needed 1 electron or 3. Okay, it needed 3 electrons, so it take what it take 3 hydrogen atoms, okay, to form the covalent bond. Is there any number of lone pairs in the arsenic atom inside this molecule? Okay, there is 1 lone pair rest in the forming the compound arsenic AsH3. Okay, we have only 1 lone pair of electrons as it not forming a bond inside the compound AsH3. It is the number of lone pair rest in the arsenic atom as it has only 1 in s orbital. Okay, which of the following choices represent the number of electrons of lone pairs and that of electrons of bond pairs in phosphorus B atom B15 inside the molecule BCl3 compound? Okay, when we are making el electronic configuration, we will have 2 8 8 2 8 5. Okay, 2 8 5. We have 5 electrons that needed 3 electrons to complete its outer level. So we have number of electrons of lone pair. We have choices A and bond pair. Okay, number of electrons of lone pair, we have before making a bond we have 1 or 2 or 2 or 4, or bond pairs we have 3 6 3 4. Okay, when we taking a 3 chlorine atom, so the number of bond pairs here 3. Okay, but what is the number of the rest electrons? Okay, number of lone pair or unbonded here. Okay, when we count them, so the right answer will be counting number of electrons of bond pairs. We will counting the electron pairs bond that forming a bond pair. We have in BCl3 that we have number of electrons of bond pairs. We have 3 bond pairs, so we have 6 electrons, and we have only 1 pair of electron, that is the rest. So the number of electron of lone pairs will be 2 of electrons. Number of electrons of lone pairs will be 2, and the number of electrons of bond pairs will be 6 electrons, that making 8 electrons for at all. Okay, let's going to question 7. Question 7 says that which of the following choices represent one of the atoms which form hydrogen cyanide HCN? Okay, when we said that we have Cn, carbon, N and hydrogen. Okay, carbon atom. We have the first one choices. Carbon atom C6 has lone pair of electrons. No. Carbon have two pairs of two lone pairs. Okay, at first. When nitrogen atom N. Okay, so we have here carbon 6. When making the bond, carbon make a bond with hydrogen, so it is a bond pair, and the three rest making with nitrogen. So carbon all have no lone pair, no lone pairs. All of the carbon are bond pairs. So the first answer will be wrong. Nitrogen atom N7 has one pair of electrons. No, as hydrogen here contains the three atoms that forming, okay, three hydrogen. We needed three electrons. That carbon will make one bond with nitrogen, and we have one pair, it will be the rest. Yes, one pair, one lone pair, it will be the rest. That carbon will make a one bond with nitrogen, and the rest will be one lone pair, will be unbonded. Okay, hydrogen has one lone pair. No, make it has only one electron that form a bond pair with it. Nitrogen has two lone pairs of electrons. No, it only has one lone pair. So the right answer will be letter B. Nitrogen atom N7 has one lone pair of electrons. Okay, let's going to, it's a very important question. We have to concentrate on this one. Okay, let's going to question 8. Question 8 says that if we have the structural formula of the opposite compound, what is the number of valence electrons of the elements of these compounds which don't participate in forming the compound? Okay, we want to know what is what is the number of valence electrons that don't participate in forming the bond. Okay, we have here the carbon surrounded by four bonds. Okay, four electron. Okay, so we have here carbon that forming bond with oxygen, four bonds with oxygen also. Nitrogen make a three bonds. Okay, what is the number of electrons that not forming a bond? We have here the right answer will be 12. The right answer don't participate in forming the bonds. Okay, we have carbon. When we are talking about the number, we are talking about the number of electrons here. The number of electrons, if bromine have only one bonded here, so we have rest, what we have rest, what we have one in the outer. So we have what we have from the 8, we have three pairs, not three pairs of electron not forming the bond in the outer shell, as it has 7 electrons, and the rest of it will form the bond. So we have 3 pairs of electrons or 6 electrons. Carbon also, we have 2 and 2 will be 4, and the 4 others forming the bond, 2 and 4, 6. Okay, 4 forming the bond, we have here 6 electrons, and also carbon, another carbon will be 8 electrons. Nitrogen here we have 5, will be, we have here 8 electrons. 2 pairs, we have 4 pairs, well 8 electrons, and 4 belongs to nitrogen, so we will have 4 pairs of electrons, so we'll have at the end 12 electrons not forming or not participating in the bond. Okay, we will write the atomic number of each one. They will give you bromine, of bromine, carbon and hydrogen and oxygen also. We are talking about Oxygen has 8 electrons. Okay, two of them, two pairs, it make two bonds, two bonds here. So we have the rest of them that not forming the bond, also 6. So we will at the rest we have 12 bonds at the end that not forming the bond, or we can say we have 6 lone pairs. We have 6 lone pairs. Which of the following compounds, question 9, which of the following compounds its solution is characterized by its ability to conduct electricity? Okay, when we are talking about this one, we are talking about the someone most most effective or conduct electricity must be ionic bond or ionic compound. Okay, let's discuss our choices. We have here ethylene, C2H4. Ethylene, it's an organic compound that is consists of covalent bond. So we have here letter A will be not the right answer. We have here letter B, potassium chloride. It's an ionic compound that consists of metal and non-metal, so it contains free ions. If it will be melts or convert into solution, or dissolving or convert into solution, so it's an ionic solution that will conduct electricity, or ionic compound that will conduct electricity, so it is the right answer here. Okay, also we have CH4, methane not an ionic compound, it's an organic compound that will not conduct electricity. The last one here we have acetylene, C2H6, that also it's not a covalent, it's not an ionic, it's a covalent, so it will not conduct electricity. We have here only an ionic compound that has the property of conducting electricity. Which of the following values represent the difference in electronegativity in a good electric conducting compound? Okay, when we are talking about it without any notes, we have from 0 to 1.7 that we have the covalent bond. After that, so when any number greater than 1.7 will be ionic compound, and it will be a good conductor of electricity. So the right answer will be letter D. Okay, all these are belongs to covalent compound. So we are going to question 11 says that in which of the following compounds the ionic character predominates means that very effective, okay, or very character, or have a high effect on the compound. Okay, we have here CH3Cl. Okay, it's a covalent compound. We have here covalent also methane, chlorine, covalent compound, polar covalent compound, but here we have ionic character that belongs to rubidium chloride. Rubidium chloride, here we have the right answer. It is an ionic compound that consists of positive and negative ion that giving the ionic character. Question 12 says that which of the following elements of group 2A forms compounds which show the properties of the covalent compounds? Okay, we have here beryllium. Okay, we have another one, magnesium, calcium, and strontium. Okay, these are elements of group 2A which show the properties of covalent compound. According to them, we have magnesium loses 2 electrons, so it will be belongs to ionic. Calcium loses 2 also and belong to ionic. Here we have beryllium will lose the 2 electrons in from the outer and belongs to ionic, and some of them will make a share for electrons. We have beryllium here forming a share of electrons that will be as a least in the atomic number. This is the last one, strontium, that also lose the outer 2 electrons. So we have here the element of group 2A form a compound, show the properties of covalent compound here, as it form a 2 single covalent bond, as it will form two single covalent bond in this compound. Let's go to question 13. The chemical formula of the produced compound from the combination of element Y and E 3s2 3b4 with element X and E 3s1 is, okay, we have here the chemical formula. X will exchange, we will write XY, so we have 4 3b6 and 3s1. Okay, when we exchange the valences, we will have in the outer here we have 6 electrons, so we needed 2, so its valency Y 2, its valency divalent, and X here we have 1 electron, so it will be monovalent when exchange valences. So X give 1 to Y and Y give 2, so it will be X to Y. The right answer will be letter B, X to Y. Okay, let's go into question 14. Which of the following ionic compounds, its cations and the anions don't contain the same total number of electrons? Okay, we have here the ionic compounds, cations and anions not contain the same total number of electrons. We have lithium hydride, lithium contains 2, and hydrogen contains 2 also. NaOH, okay, when you are talking about this, Na will be 10, oxygen will be reaches to 10, and hydrogen OH as a group will be 10, will be followed by making a one bond. NH4F will make a bond here, we have a group, and this is the element. These two compounds are bonds as a compound. Here we have compounds that consist of atomic group that making the not the same number, but we have here the monovalent, and each one here is monovalent. We have titanium titanium trichloride TiCl3 that don't contain the same total number of electrons. When we make a bonding, as it will make 3 titanium, we have here make a 3 covalent bond. So we have chlorine will contain here chlorine 17, so it will make greater than number, as a titanium has a high atomic number or has a high number of electrons. So the cation and the anion here don't have the same number of electrons. Let's go to question 15. Question 15 says that the opposite figure represent, we have here the covalent bond. Which kind of covalent bond? Okay, we have an ionic compound. No, it's not an ionic compound at all. Polar covalent. Do you think it's a polar? Okay, a pure covalent, and an acidic compound. Okay, when we are talking to this one, we have the right answer will be polar covalent. Why polar covalent? As one of them has a greater number of electrons than the other. Okay, polar covalent, as the number of electrons here, we have greater number of electrons of the Y atom, and center will be Z that has a less, there is a different in the electronegativity between each one. Okay, question 16. In terms of opposite table, which of the following bonds is more polar? Okay, we have choices. We have hydrogen, carbon, nitrogen, and oxygen. Between carbon and the hydrogen, if we make a subtraction, we have 2.5 minus 2.1 will be 0.4. NH will be 3 minus 2.1 will give also 0.9. We have OH, we have 3.5 minus 2.1, we have what? We have 0.4. C and O, we have what? We have 0.5. So the greater in the number we have here, what we have, OH, as the difference in electronegativity between them will be higher, so it is will be more polar covalent, or more polar between the oxygen and the hydrogen. We have 3.5 and 2.1. The difference between them will be the greater one, so it is more polar than the rest of them. Okay, we have 3.5 minus 2.1. Okay, it will give 0.4. This is the right answer. Let's going to question 17. Question 17 says that which of the following compounds is more polar? Okay, we have the electronegativities of their elements are hydrogen 2.1, nitrogen 3, oxygen 3.5, and fluorine 4. Okay, we have NH3, NF3, we have the more polar NO2 and HF. We have the electronegativity N and H. Also we have N and F. We will make the difference between N and H. We will have 3 minus 2.1 will give 0.9. N and F, 4 minus 4 minus 3 will give 1. Okay, we want the more polar. Okay, and N and O, 3.5 minus 3 will give 0.5, and H and F, 4 minus 2.1 will give 3, will give 0.9. So the right answer will be HF. Here we have HF, as the difference in electronegativity will be greater, so we have the more polar compound here. We have what? We have the more polar compound will be HF. Okay, as it has a one only polar, one covalent bond, as it has one covalent bond, and its electronegativity will be the higher, so it's more polar. Which of the following, question 18, which of the following halogen atoms that surrounds the carbon atom in the opposite figure attract the bond electrons more? Okay, we have chlorine, fluorine, iodine, bromine. Okay, which one will attract? They are all surround the carbon atom. Okay, according to each of them, we have the only one that has a higher electronegativity that will attract the bond of electrons more. Again, when the one has high electronegativity, that will attract the bond of electron bond greater, that has high difference in electronegativity. The greater one of them, we have the group halogen, fluorine, chlorine, bromine, iodine, the highest one in electronegativity, as the it has a big smallest in the atomic size, and the electrons are nearer to the nucleus, so the highest one that make the electrons surrounded to it and nearer to it, that make attraction and make the bond attracted to it, will be the fluorine. Okay, question 19. In which of the following pairs of electrons of elements the covalent bond between the two atoms is more polar? Okay, we have here, in which of the following pairs of electrons the covalent bond between the two atoms is more polar? Okay, we have here chlorine and bromine, chlorine and iodine, fluorine and chlorine, and the last one, fluorine and iodine. Okay, when we are discussing this one, we have the more polar will be what? Will be not the more polar will we must have one has high atomic, one has high electronegativity, and one has low. When we make a comparing, the first, as we say in the group halogen, we have fluorine has highest, and we will have the least one, we will be fluorine and iodine, one the up and one the down. One up fluorine, chlorine, bromine, iodine, and the least one, there is the big difference between fluorine and iodine, that making it its compound will be that high, what high difference or more polar between the two atoms when making a covalent bond. Okay, let's go to question 20. Question 20 says that illustrate by drawing Lewis dot diagram of the combination of one selenium atom 34 and with the two hydrogen atoms to form H2SE molecule, selenium hydride or hydrogen cyanide. Okay, so we have here hydrogen 1s1 and selenium 34, we have argon 18 and 4s2 3d10 4b4. Okay, when we make a compound we have one electron in H and what, and we have here four electrons. How we can calculate them? 4b, we have 4s and 4b. Okay, 4s we have the first one 2 up down 2 and right and left. Will have unpaired electron that each one will take two hydrogen atom. Each one will take one hydrogen atom, so the chemical or the Lewis dot diagram will be as we say, or as we see that we have here selenium in the center surrounded by up lone pair, down lone pair, we have two lone pair and two bond pair in the selenium hydride molecule. Okay, let's going to question 21. Question 21 says that draw Lewis electron dot symbol for an atom of representative element X, which contains three principal energy level and its outer level contains two unpaired electrons only. If we are talking about this one, we have three principal energy levels, so we have 1s2, 2s2, 2b, or 1 and 2, 3. Okay, its outer contain two unpaired electron, so its electronic configuration will be 1s2, 2s2, 2b6, 3s2, 3b2. Okay, we have the in the 3 we have 4 two unpaired electrons in the 3b, and the 2 in s we have 2, we have this electronic configuration X, we have 1 1 1 1, we have 4 unpaired electrons, so its outer level contains two unpaired electrons only. Okay, we can draw this as X, we have two pairs above X and one right and one left, that making unpaired electrons. Okay, let's going to question 22. Question 22 says that write electronic configuration of the element Cl17 calcium 20 according to Aufbau principle, then conclude the type of bond that is formed between them and the formula of the product of their combination together. Okay, with what we are saying, Aufbau principle, that we have only that bond pair that will be filled the orbitals at first and unpaired electrons at the end. Okay, if we are talking about chlorine 17, we have 1s2, 2s2, 2b6, 3s2 and 3b5. Okay, when we are talking about calcium 20, 1s2, 2s2, 2b6, 3s2, 3b6 and 4s2. The type of bond between them, if we are talking about each one, calcium is metal and chlorine non-metal, that calcium lose two electrons here, and chlorine gain one electron, needed to gain one electron, so it will form ionic bond. Okay, calcium lose two, giving it to the chlorine, and chlorine will make a bond that take that formed the ionic compound with two electrons, with two atoms of chlorine, that each one take the electron from the calcium atom, so the formula of the product of their combination will be CaCl2. CaCl2, it is the ionic compound that formed from the reaction between the calcium and chlorine, and it's a covalent it's an ionic compound that not forming a strong ionic, but it's less stronger as it belongs to alkaline earth metal, so it form an ionic compound. Let's go into question 23. Question 23 says that assists by the opposite figure. Mention with explanation the symbol of each of. We have a compound doesn't conduct electricity. When we have compound that don't conduct electricity, we must have an ionic compound. And also we want a very good electric conductor. When we take a very good electric conductor, this is the second one, we take the least one in electronegativity and the highest one in electronegativity and make the difference between them, so we have a very good conductor. So it is the easy one here to make a difference between chlorine and sodium, that giving a good, very good electric conductor. So between what, between sodium and chlorine, and it will give NaCl. The other one don't conduct electricity will be Al and Cl, that the difference between them will be decreases. So 3 minus 1.5 will be 0.5. So it is the less one in the difference in electronegativity, and it will not conduct electricity. So we have the first one, AlCl3, because the difference in electronegativity between its element will be here 3 minus 1.5 will give 1.5. So it less than 1.7, it will not an ionic compound, it will be a covalent compound. Also, as I said, we have the easy one, NaCl, because it is the difference in electronegativity between its element. 3 minus 0.9 will give 2.1, so it is greater than 1.7 and it is an ionic compound. Okay, let's go into question 24. Question 24 says that illustrate the type of chemical bonding in each of the following molecules. We have here M plus X negative, it's an ionic bond. Okay, each one M lose and M lose 1 and X gain 1. Here we have a covalent bond, each one share with 1 electron, so it will be what, it will be single covalent bond. Here we have what, we have also single covalent bond, each one share with 1 electron. So we have here the first one, ionic bond. We have here polar covalent bond, as it each one we have different atoms, and we have here pure covalent bond, as we have the same atoms that sharing with the same number of electrons. Okay, question 25 says that by using the following table, okay, that shows the electronegativity values of some element. We have all the elements and all the electronegativities. Okay, arrange the following bonds in an descending order according to the graduation in ionic property. Okay, if we make a difference between Na and Cl, it is the high difference between them. Okay, KCl, CaCl, and MgCl. Okay, as we said, we have the highest one. We want to arrange the bond in descending. We will start with Na, it is the highest one, followed by, no, we have the KCl, it is greater in atomic mass than Na, so we will start with the highest one. Here we have 0.8 minus 3 minus 0.8, so the highest one in difference in electronegativity will be KCl, and least than it NaCl. Below them we have CaCl and MgCl. So the highest one in electronegativity, KCl higher than NaCl, higher than CaCl, higher than MgCl. Okay, also we want to arrange in descending order polarity of the molecule of Ci, Cf, CCl, and CBr, carbon iodide, and we have wanted to know each one. Okay, arrange according to the polarity, as we said that we take the highest one in electronegativity. We have here fluorine, okay, fluorine 4, and carbon, okay, 4 minus 2.5, so the highest one will be Cf, and without numbering, when we said that we have chlorine, chlorine, bromine, iodine, the highest one will be fluorine. Chlorine less than it, so we have Cf and CCl, bromine, After that CBr, and the last one will be iodine, as it has the least one in the electronegativity. So we have descending order will be CFCl, CBr, Ci. Okay, the last one here, CH4, H2O, HF, and NH3. If we make the highest one, so we take, as we said, that we have fluorine, that highest one, it will be the first HF. That below it will be the difference between oxygen and the hydrogen, as it has high in electronegativity, will be 1.4, the high polar covalent compound. So hydrogen, HF, hydrogen fluoride, below it will be H2O, 1.4, the difference, and below it will be NH3, and the difference in electronegativity between them will be 0.9. And the least one, we have carbon and oxygen, the least one in electronegativity will be 0. Will be 0.9. Okay, so we have here HF greater than H2O, greater than NH3, greater than CH4. Okay, question 26. This is the last question of our group of questions today. Choose from the following pairs of bond the more polar bond in each pair with giving reason. Okay, we have here carbon and nitrogen, carbon and oxygen. Okay, we said that we have the more polar, that higher in difference in electronegativity. Okay, when we said that the difference electronegativity between two combined element in the polar molecule increase, when the number increase, the polarity of the bond increase. So when we take that electronegativity of oxygen element here, oxygen with carbon, higher than the electronegativity of nitrogen and carbon. So the difference in electronegativity between carbon and oxygen higher than cyanide and higher than carbon and the nitrogen. So the correct choice will be CO. Okay, electronegativity of element F higher than the electronegativity of bromine. So when we make a bond, the bond pair NF has high electronegativity than what? Than NBr. So the right choice will be NF. The correct choice, it will make a high polar covalent bond. Number 3, S and N and O. When we have the difference in electronegativity, oxygen has higher electronegativity than sulfur. Okay, so when we make the bond, we have NO has higher electronegativity as a bond in SN. So the right choice will be NO or ON, as we write in our compound. Okay, this is the last question of our group today. I hope you enjoy this part of question. Please study hard. This is the first lesson of our questions. I hope you can understand any questions. If you have any comments, please send it in any way of communication that we have. And I hope you enjoy this part of MCQ questions. If you have any problems, please write it below the video. Okay, thank you and goodbye.